Hello dear students, welcome back to my channel. I hope you all are doing the homework, and let's go to our next video, that is colligative property. So before entering to this property, I would like to say about the azeotrophs. Recap of last video, that is ideal non-ideal solution. The solution which obey Raoult's law is known as ideal solution, and the solution which doesn't obey Raoult's law, it is known as non-ideal solutions. And again, non-ideal solution shows two type of deviation, that is what positive deviation and negative deviation. Is that clear? Next, azeotroph. Azeotroph is a type of solution. Azeotrophs. These are the type of solution where if you will try to separate these solutions, solution means solute plus solvent. If you tries to separate these solutions, it will same in case of your solution phase and also in vapor phase. That means some solutions having same composition in liquid phase as well in vapor phase. You can't separate by applying heat. Those type of solutions are known as azeotropic solutions. It is again of two types: minimum boiling azeotrophs, minimum boiling azeotrophs, and maximum boiling azeotrophs. Minimum boiling azeotrophs means minimum temperature, it will, by applying minimum temperature, it will goes to the vapor phase. That is what minimum boiling azeotrophs. For example, 95% ethanol in water by volume. Okay, and maximum boiling azeotrophs example is 68% of nitric acid in water by mass. Nitric acid in water by mass. So these are the example of maximum and minimum boiling azeotrophs. Okay, understood? So next we will move towards the colligative properties. Solution shows colligative properties. So what is this colligative property? Colligative property is that property which depends on the number of solute particles, of the solvent of the solution, irrespective of the nature of that particles which are dissolved. Okay, it depends upon the number of solute particles, how many solute particles get dissolved. Some solutions have 100 number, some solutions have 1000 number of solute particles. So there must be some difference in their temperature irrespective of their nature. So these kind of properties are known as colligative properties, and these colligative properties are of four types. First is relative lowering the vapor pressure. This is first. And thereafter elevation in boiling point, depression in freezing point, and then osmotic pressure or osmosis. We'll go one by one. So first is relative lowering the vapor pressures. So we know that Raoult's law. What is Raoult's law? Partial pressure is directly proportional to the mole fraction. Yes or no? Of that equals to P1 naught zeta 1. This is what your Raoult's law we already got. Okay. So consider a container having some liquid, pure liquid, suppose I will take it. And as I am telling about the vapor pressure, that means it must be closed. And what some of particles, these liquid particles, get vapor. And simultaneously these vapor will condense and again it forms liquid. Yes or no? So it's on an equilibrium system. What happens at a time, the pressure will remain same. Some pressure will exert here, some pressure will exert here, some pressure will here. So the pressure exerted to the surface, yes, यहाँ से जो particle होगा वो तो pressure exert नहीं करेगा. So the vapor pressure which is present at this atmosphere and it applying pressure on the surface of liquid, that is what the vapor pressure. In case of pure solvent, so this is what vapor pressure of pure solvent, P01. Because I am not taking any other liquid, only one liquid I have taken, only one solvent I am taken, and it creates pressure due to the presence of vapor over there. Okay. If suppose I have added non-volatile substance or solute, what I am added? Non-volatile substance if I add here. So this is the vapor pressure of pure solvent, right? If I am added some substance which is non-volatile in nature, so what happens? This non-volatile will block some areas. Again, it will block some surfaces also. So the amount, the formation of vapor will goes decrease at the particular temperature. Yes or no? And simultaneously the pressure will again decrease at that same temperature. Okay, but this is what your relative lowering the vapor pressure. When you are adding non-volatile substance to a solution, it lowers the vapor pressure of the solution. Am I clear? Okay, so what's the difference if you added one more solute? Let's say, so what is the difference? It must be the difference. This P0 is the pure solvent vapor pressure and P1 is the partial pressure by adding this, or it is the pressure of the solution, you may say. So this difference, how much lowers the vapor pressure, that you can calculate it. Yes or no? So this equals to, we know that P01 zeta 1. So actual pressure, if you will calculate, this is the difference. And again P01 zeta 1 को हम क्या लिख सकते हैं? 1 minus zeta 2. Yes or no? Or P01 minus P1 equals to P01 zeta. Yes or no? Okay. So this is what lowering the vapor pressure. This is not the relative lowering the vapor pressure. How will you get the relative lowering the vapor pressure? By dividing the pure pressure. So by dividing the pure pressure, you will get relative lowering the vapor pressure. That means equals to P01 zeta 2 by, so you cancel. So what you are getting? Relative lowering vapor pressure equals to mole fraction of solute. 1 stands for solvent, 2 stands for solute. Okay, right. For a dilute condition, zeta 2, instead of zeta 2, what you can write? N2 by N1 plus N2, yes or no? Zeta 2 is nothing but your mole fraction, and mole fraction zeta equals to zeta A, or zeta 1 equals to N1 by N1 plus N2, or zeta 2 equals to N2 by N1 plus N2, yes or no? N is nothing but your number of moles. If it is 1, then number of moles of solvent. If it is 2, number of moles of solute. Okay, so in case of dilute condition, in dilute solution, the addition of solute, suppose N1 is very diluted, N1 is very large, solvent is very large, the large amount of solvent is present over the solution, and N2 is very small amount of non-volatile solute you are adding it. Is there any different? Is there any it will form any difference over there? No, because the N2 will be very less, and that can be neglected. So in dilute condition, you can write the relative lowering the vapor pressure is equals to N2 by N1. So remember these two formulas that you are going to use this formula for solving these RLBP solutions. Okay, let me clear this. So next colligative property is your elevation in boiling point.